We are continuing on graphing systems of equations, but we're going to use those other two that I talked about yesterday. So yesterday I said the only choice was that they cross once, and today we are going to look at all three of the possibilities. So that's that they cross once. Okay, I don't like the way I wrote that. They cross once. Okay, and so that looks like this, and you were looking at those yesterday. They never cross, and we call those parallel lines. That looks like this. And then they always cross, or in all places. And we have a special word for that. And that's when two lines literally are the same line and they lie directly on top of each other and they share all the points in common. So just like I was doing yesterday, I'm going to try to graph these in different colors. So my blue line is y equals 4x plus 7. So that means my y-intercept is 7. And then I'm going to go up 4 and over 1. Okay, so when I go up 4 and right 1, but I can't, right, because I don't have any more. So to work backwards, I'm going to go down 4 and left 1. 1, 2, 3, 4. Okay, so just opposite, but you will see that I still am puff positive here. Okay, if Slope Dude was on my ski hill, he would be going uphill. All right, then I've got in red 3x plus 5, so I'm going to put a dot at 5, and then I'm going to go up 3. Oh, and same thing I'm running into, so I'm going to try and work backwards. Down 3, right 1. Down 3, right 1. I can already see where my two lines are crossing because I just overlapped my dots, so that's good. I did a bad job there of lining up my lines. Okay, but the solution to this is solution is -2, -1. Okay, so they cross one time. I do have a system of equations and a solution that is 1 point where they cross. Okay, so maybe I'll write that. This has one solution. All right, if you're not done with this, you should pause and then start again. All right, so I have two lines here that have the same slope and different y-intercepts. They will never intersect. There is no solution. These are parallel lines. So this one I'm asking you to write. Okay, can you write the system that is graphed? So when I look at this first one, number 1, looks like my y-intercept. Oops, that is not my y-intercept. My y-intercept is at -2. So I have -2 out here. And if I go look up 2 over 1, up 2 over 1, that's +2 for my slope. Now the next one, because it's parallel, I expect the same thing. And I can see for this one that my y-intercept is -1. And I go up 2 over 1, up 2 over 1. So if they have the same slope, and we have talked about parallel lines in Unit 1, and different y-intercepts, then they are parallel. Okay? So what happens, why did I make a big deal of this, right? If they have the same y-intercept, then they're going to be the same line. And I have a feeling we'll probably run into that. All right, some of us are still struggling a little bit with graphing in standard form. So remember, in standard form, okay, we can find the x and y intercepts. So I'm going to plug in 0 for x here. So if I do 6 times 0 minus 2y equals 12, this part goes away because 6 times 0 is 0. I would divide both sides by -2 and get that y equals x. I'm going to repeat the process, but now plug in 0 for y. So 6 times x minus 2 times 0 equals 12. Okay, this chunk goes away. There's -2 times 0 is 0. And then I'm going to divide both sides by 6 to get +2. Okay, so I'm getting questions like, Mrs. Vogt, where did the zeros come from? We are choosing the zeros because that's how we find the x and y intercepts. So 0 over 6 down. 1, 2, 3, 4, 5, 6. Okay, remember it goes left and right, then up and down. And then over 2 and up 0. And then I'm going to do my best to draw a nice straight line. For my red line, I'm going to start at 5. 1, 2, 3, 4, 5. And I'm going to go up 3. Oops, that happened again, right? I'm missing a line, so I'm going to work backwards. Down 3, over 1. Down 3, over 1. Down 3, over 1. And if you did a good job, let's hope I did. Okay, I think we'll see that these lines are parallel. How can I tell for sure? I could look at my blue line. Let's see, up 3 over 1, up 3 over 1. So the slope of this line is also 3. The slope of my red line is 3. They have different y-intercepts. Okay, these are parallel lines. They never cross. They have no solution. Okay, so if I asked you for the solution to this system of graphs, you would graph them and find out that they are parallel and there would be no solution. All right, you should try this one on your own. Why don't you hit pause now? I'll graph it and then you graph it. And then see if our answers match. So first I'm going to find my x and y intercepts, and once I find those, I can draw my straight line through them. And I can count too. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I went down 4 and right 6. So the slope of my line here, and I'm just counting it for myself, is -2/3. And I can already see when I graph my red line, I have the same slope. So instantly I might think these are parallel. But the next thing I noticed, 1, 2, 3, is that all my dots seem to be lining up. So what happened? Blue line, and if I would have drawn a little bit better, you would have seen the red line lies right on top of it. These two things are the same line. Okay, we have a special name for this. It's called coinciding. Okay, and it means that they meet at every point. Okay, so every point that you can think of that's on one of these lines, it's also on the other line. So what would the solution to this be? It would be all solutions. And we use, like I said, we're going to use this word, this new word called coinciding. Okay, so how do we solve by graphing? Adding in from yesterday, we found where they meet, like the X, that spot where they meet. Then today, adding in the new ones. Okay, so you're going to graph the y-intercept and the slope, or graph the x and y-intercepts. Okay, determine if they're parallel. If they're parallel, the answer is no solution. If they are intersecting, which means they cross, you're going to have one solution. If they are coinciding, that means they are the same line and they have infinitely many solutions. Every point on the line matches. Okay, if I was making a pink note sheet for a test where I took this, I would write these things down. Okay, writing examples might seem important, but this will help me if I don't remember. Okay, these are important things. So it says classify, right? This is intersecting. Let's spell it intersecting. It has one solution, and then give me that one solution. Over 2, up 3. Over 2, up 3. When I look at the next one, I'm like, whoa, there's only one line. And that can only mean one thing. There are two lines that lie on top of each other, so this is coinciding. Okay, you could also say all solutions. All numbers are solutions. And then example number 3, these are parallel lines. so they have no solutions. Okay, below is your homework. Yes, you need to do it. Okay, so some of these are in standard form. There's a nice spot for you to write them in slope-intercept form. This helps you determine, I'm going to say helps decide if parallel. It'll actually kind of help decide if they're coinciding too, because they would have the same y-intercept and the same slope. It's harder to see if they're parallel when you're in standard form. So that's why I gave you a spot to do slope-intercept form. Okay, and then you need to tell me the classification. Okay, classification means does it have one solution, infinitely many or all solutions, or no solutions? And that goes in this spot right here. All right, good luck.